there is a metal on the Earth is more than exceeds that of lead, copper, and zinc combined. But until the 1940s, humans finally figured out how to refine it. It's not because it's hidden deep, but because it's too sticky. Its relationship with art to an outrageous degree. This thing is called titanium. You should know, titanium is the 9th most abundant element in crust. But you can't find a piece of pure titanium in nature, because once it meets oxygen, hydrogen and nitrogen, it immediately binds to them, locked in compounds. It's this damn property that titanium was discovered to be useful, that it took nearly 200 years. Note that titanium ore is mainly hidden in 2 minerals. One is called ilmenite, and rutile. Australia, South Africa, and Canada are the world's largest producers. The mining method is not very complicated. It's dug out by heavy machinery, and then crushed and cleaned to separate the type. Separated from a pile of waste rocks, it's not so difficult. The trouble is later. The real tough part is the crawl process. In the 1940s, a Luxembourg engineer named William Kroll. It took him more than 10 years to complete this process. Now, it is still the mainstream method for extracting titanium. Wow! How does this process work? The first step, mix titanium with chlorine and carbon into a reactor to a temperature of, at this temperature, chlorine and titanium react. A substance called titanium tetrachloride is produced. It's liquid, highly volatile, and extremely active. Then through distillation, filter out the remaining iron and impurities, leaving pure liquid tetrachloride titanium. The second step is key. Put the titanium into a sealed container filled with magnesium or sodium, and vacuum or inert gas is filled in to prevent air from mixing in. Magnesium and titanium tetrachlorine away, and titanium is reduced in this way. What is the product? It's a grayish-looking, porous metal block with small holes. Scientists call it titanium sponge. It's this thing, which is the original form of pure titanium. Titanium sponge can't be used directly. It must be remelted, usually a vacuum arc melting furnace or an electron beam furnace. The core is to complete it in a vacuum, because as soon as titanium touches air, it starts to rise secretly. Then it is cast into large titanium ingots, which is the raw material for further processing. Then titanium ingots need to be forged, pressed or extruded to become various shapes of plates, rods, and pipes. This step requires repeated heating and forming, which is very time-consuming. It is worth mentioning, pure titanium is powerful, but it's truly amazing when alloyed. The most common formula is to add aluminum and vanadium, which is called T6L4V, which means titanium, aluminum, vanadium. This combination retains the lightness and corrosion resistance. It also greatly improves strength. It's a favorite in aerospace and automotive industry. Boeing, Airbus, and SpaceX's rocket engines contains its components. Processing titanium is notoriously difficult. It's too hard and doesn't dissipate heat. When cutting with tools, heat cannot be quickly removed, and the knife is often burnt. Special tools and cooling techniques are required to cut it open. Titanium used in medical need to be polished to a mirror finish. The surface also needs special treatment to make it compatible. Titanium parts for aerospace also need to be heat treated to further improve its strength and durability. After this whole process, the production cost of one is 5 to 10 times higher than aluminum. Since it's so troublesome, and why do we still use? The answer is simple. It can do what no other metal can replace. It weighs half of steel but has the same strength. It can withstand temperatures above without deformation. It won't rust in seawater for decades and won't be rejected in the human body for decades. Combining all these conditions, you can't find another metal that can meet all of them. By the way, its appearance is quite interesting, with a silver-grey base, but if it is treated with a nut, it will reflect different colors according to the thickness: blue, purple, gold, and green. Without dyes, it's all about physics. That's why titanium is used to make high-end watches and jewelry. So titanium is not a rare resource on Earth. It's everywhere on Earth. But from our two finished product: greening, distillation, reduction, vacuum smelting, forging, alloying, and finishing, every step has to fight this metal. Its wild nature to combine with everything around it. Humans spent 200 years taming it, which has led to the thin titanium. Those thin titanium alloy skins, and the silver-grey watch case on your wrist. To put it simply, it's not a piece of metal. This is a trophy of 200 years of struggle.